use Laplace transform to solve the following initial value problem. Y double prime plus 4y equals gt, y at 0 equals 0, y prime at 0 equals 0, where gt is given by this piecewise continuous function. Okay, so let's write this g in terms of unit step function. So this g is in fact first piece 0 plus the unit step function at 5, or Heaviside function at 5, second minus first. So u5t unit step function, second minus first, second piece minus first piece, just you get that, plus these two functions differ at 10, so the switch or the Heaviside function at 10, so u10t, third minus second piece, 1 minus 1/5 t minus 5. Simplify this, you get 1/5 10 minus t, so which is negative 1/5 t minus 10. So our g function is in fact 1/5 unit step function at 5 t minus 5, 1/5 unit step function at 10 t minus 10. Now we want to take Laplace transform of this differential equation. Just take Laplace here. Okay, take Laplace. Then we get Laplace of y double prime, which is from table s square Laplace of y minus s y0 minus y prime 0, plus, so let me put this, plus 4 Laplace of y, 4 Laplace of y equals Laplace of gt, which is here Laplace of this part. So 1/5 constant, Laplace of u5t t minus 5. Okay, using the table e to the negative 5s, and Laplace of t, which is 1 over s square, minus, same thing here, 1/5 unit step function t minus 10, so that's e to the negative 10s, and Laplace of t, which is 1 over s square. Okay, now let's use the initial conditions. Y0 is 0, so s times 0, the whole thing is 0 now. Y prime 0 is also 0. Then we can factor Ly out from these two terms. Then we get s squared plus 4 Ly equals, in the right hand side we just keep writing whatever we have. We can factor 1/5 out and 1 over s square out as well, so 1/5, okay, not, yes, this is 5th, 1 over s square out, e to the negative 5s minus e to the negative 10s. Now divide by s square plus 4, then Laplace of y equals, divide means multiply on the top, so 1/5, 1 over s square already there. Now we are dividing by s square plus 4, so I want to keep this together, times e to the negative 5s minus e to the negative 10s. Okay, now to recover y back, to find the y, we need to take inverse Laplace. We got a product here, so we want to write this as a sum or difference of two functions, two simpler functions. Look at here, this is a factor, we got two factors, so let's do the partial fraction decomposition over here. Okay, then by partial fraction decomposition, 1 over s square times quantity s square plus 4 equals a over s square plus b over s square plus 4. Both are quadratic factors, so we don't have to write as plus b. This works, and here is the case. So this is same as 1 over 5, and this thing is a 1/4 s square, so this is in fact 1/4 s squared, plus b is negative 1/4 over s square plus 4. Okay, and now we know how to take the inverse Laplace of these two, times e to the negative 5s minus e to the negative 10s. We got a product, but there is no product rule for Laplace transform. So we need to distribute this to these two terms. Let me do this. Let's assume this for a moment. Let's say this is h of yes. Then this becomes, now I can distribute this easily. I don't have to write everything. And this is 1/5, okay, e to the negative 5s hs minus 1/5 e to the negative 10s times hs. That's the Laplace of y. Now let's take the inverse Laplace, and when we find the inverse Laplace of h, that will be little lowercase h, that we can find that over here. Okay, take inverse Laplace both sides, then we get y as a function of t. And look at the table. So when we have e to the negative cs, some function of s, and take the inverse Laplace, we get 1/5. Okay, this is coming from the unit step function, so u5t, and lowercase h, because it's uppercase h, so lowercase h t minus 5, where lowercase h is the inverse Laplace of uppercase h, that we're going to find in a moment, minus 1/5. So take the inverse Laplace, same thing, u10t h t minus 10, where the h, this h function, is inverse Laplace of uppercase h. Okay, and done. So just find lowercase h and write down that is t minus 5, then done. Okay, so let's find ht. Okay, now h is inverse Laplace of this. So inverse Laplace of uppercase h is here, 1/4 1 over s square minus 1/4 1 over s square plus 4. Let's take the inverse Laplace. 1/4 constant, 1 over s square is t, because Laplace of t is 1 over s square, minus 1 over s square plus 4. We need 2 over s square plus 4, that would be sine 2t. So let's multiply top by 2 and divide by 2. Now 2 over s square plus 4 is Laplace of sine 2t. So this is 1 over 8, and that's the inverse Laplace of this is sine 2t. Okay, then the final answer, we go back here, that's the final answer. Y, the solution of the initial value problem, is 1/5 unit step function, Heaviside function at 5, ht minus 5. This is ht, so t minus 5, so we need to write t as t minus 5. So this will be then 1/4 t minus 5 minus 1/8 sine 2 t minus 5, so 2t minus 10. Okay, that's the first part, minus basically the same thing, but we have now h t minus 10. So 1/5 u10t h t minus 10. So here is ht, so we replace t by t minus 10. So 1/4 t minus 10 minus 1/8 sine 2 t minus 10, so 2t minus 20. Okay, so these long two terms are the solution of the initial value problem. Final.